guys, welcome to the video. Today we're going to be learning how to perform integration by parts using the heaviside method. We're going to come to a clear understanding of when this technique is used and how to perform it. This is perfect for Calculus 1 or 2, depending on when you would learn it, and an AP Calculus BC course. This is not included in the AP Calculus AP course. So let's get right into it. So to start, when do we use it? The heaviside method. Alright, so you're going to use it when the bottom factors, or the denominator, and the bottom degree is higher. So denom factors So a clear example of this would be an example that we're going to do later. So something like 5x minus 11. So you have a degree of 1 on top. Review your rational functions if you forget this. So something like x squared minus 2x minus 8. And always make sure you have the differential in there, dx. So this is an example of when we'd use it. So obviously we're integrating. This isn't something that we could clearly integrate using any of the techniques that we already know, so that's why we're going to be applying this trick. And keep in mind that if something isn't going to factor nicely, we're going to have to do integration by parts differently using a matrices approach. But today we're learning the heaviside method. Okay, so keep in mind when you're using it, because then you'll just see something like this and you'll know, oh, I need to factor the bottom and apply this method. So here's our example we're working with. Let's start out by factoring the denominator. Your factoring skills should be pretty sharp. I mean, we are in a calculus course. Make sure you double check, make sure you didn't do a silly mistake with the signs. X squared minus 4 plus 2 minus 8. We're good. Alright, so we know that whenever we take the log of something and then we derive that, and we're talking about natural log in this case, you want the top to chain. In this case, we have just plain old x's. These are going to chain to 1, so we don't have to worry about that. But definitely always make sure that if something changes, there's a negative sign or something, you want that to apply. In most cases, we're not going to have to worry about that. However, to apply the heaviside method, what we do need to figure out is that coefficient in front of the natural log. Because right now, if we were to derive, d dx of a ln of x plus 2, that's what we're concerned with. We're trying to figure out what this a value is, because we already know that x plus 2 is going to go on the denominator. So, how are we going to do it? Well, heaviside. So what we're going to do here is, if we were to do x plus 2 equals 0, x would be negative 2. What you're going to do is plug this into the part. We're going to go back over here. We're going to cover up the x plus 2 and plug in negative 2 for the rest of the functions. So let's do that. So if we had negative 2 covered up, we'd get negative 10 minus 11, negative 21 over negative 6. Correct? So we get negative 21 over negative 6. And you're going to put that up here. Now, think through how we're going to do this one. So we would be plugging in x minus 4 equals 0. So we're going to plug in x equals 4 to what part? Cover it up, cover up what we're working with, plug it into the rest.
So it would be 5 times 4 minus 11 over 4 plus 2.
Now, what are we left with? We are left with the integral of 7 over 2, correct? X plus 2 dx plus the integral of, I just want to write this out again so you can see the process, 8 over 6, which is going to be the same thing as 4 over 3 for x minus 4 dx. Makes sense? It's pretty easy. So finally, this is super easy to integrate. It's just using your natural log, right? So we get 7 over 2 ln x plus 2 plus 4/3 ln x minus 4. What am I missing? Fabulous, plus c. That fell out of the frame, but we have a plus c. All right, we got a new equation. Can you quickly figure out if we're going to apply heaviside? Yes, you can. The denominator is bigger. We can factor it. We're good to go, but we're not good to go because I forgot that dx. So let's get going. You remember, they might be a multiple choice question. These are normally in multiple choice questions if you're going to see them. In terms of AP Calculus BC, they might already be factored, but let's go with the harder version of not. So we're going to factor that into, correct, x squared plus 2 minus 6 minus 12. Perfect. And then we have this 2x minus 1 still over here. What are we going to do? Separate it out. All right, you guys tell me what's going to be the coefficient. 6. We're plugging in 6, right? X minus 6 equals 0. So 2 times 6, 12 minus 1, 11 over 8. Negative 2, we're plugging in negative 2, covering up the x plus 2. Negative 4 minus 1, negative 5 over negative 8, so 5/8. Tell me the final answer. Let's see here. And that's a wrap. Thank you so much for watching this video. If it was helpful, please drop a thumbs up because it helps support my channel, and feel free to subscribe. If you have any video requests, I'm going to be making a lot of calculus videos, so drop them below. Thanks for watching.